everyone. Thank you for joining us today. We will be talking to Dr. Grace Danao, Research Associate Professor at University of Nebraska-Lincoln. She's joining us today. Hello, Mary Grace. How are you?
I'm doing pretty good. How are you?
Great, thanks. Thank you for accepting this invitation for this session of the Innovation Week. The floor is yours.
Sounds great. Thank you. All right. Well, thank you for giving me the opportunity to share a little bit of work that we're doing at the University of Nebraska-Lincoln, and also talking about a topic that's near and dear to a lot of food engineers' hearts, and that is to look at the intersection of food safety and sustainability. In this particular case, the use of HPP to upcycle fruits, vegetables, raw meats, especially any of the byproducts of processing these particular ingredients. As Daniela mentioned, my name is Grace Danao. I am a research associate professor in the Department of Food Science and Technology and the Food Processing Center at the University of Nebraska-Lincoln. So, the Food Processing Center is a multidisciplinary resource for the food industry. We provide a combination of consulting, educational, technical, and business development services. The lab that I specifically head is the High Pressure Processing Services Laboratory. It's part of our applied research and engineering space. And I'm always tickled when I get a chance to meet with entrepreneurs and also work with Hyperbaric, especially on the educational piece about this particular technology. So, the work that I'm presenting today is really a work that is a combination of a lot of students' research work. And currently, the team that I lead includes Prashant Dahal, who is a research technologist, and also Juliana Nino Fuerte, who's one of our graduate students in this space. So, without further ado, let's talk a little bit about some of the topics that I want to cover this afternoon. Some of it may be a repeat of other presentations in HPP Innovation Week. It's always good. More repetition is always good when it comes to education and training. So we'll go over a couple of key HPP fundamentals, benefits, and how HPP really go hand in hand with sustainability. And then I have a couple of examples where HPP has been used or is being explored in terms of upcycling different kinds of byproducts. And at the end, I'll have some closing remarks. So, to start off with, let's look at HPP fundamentals. This is a very crude diagram of what happens in HPP. As most of you already know by now, hopefully, products in their final packaging are typically loaded into baskets, which are then loaded into an HPP chamber. So, once it's inside the chamber itself, let me see if I can also bring up a laser pointer. So once it is in the chamber itself, water is going to be pumped into the HPP chamber to help apply the isostatic pressure. And the products are going to be held at that pressure for a period of time. So normally in the US, a lot of what I'm seeing is 87,000 psi or 600 megapascals for at least 3 minutes. Some products can make it for only a 2 minute holding time, really depends on some of the properties of the products. And for now, the goal really of HPP or its greatest use in industry is for cold pasteurization. Once you've achieved that pressure for a particular holding time, then the process is complete. So the water recedes and the baskets are ejected, and whoever's the processor can then start to unload the products. In terms of best practices, I mentioned earlier, some products, we would always start off by trying, let's say, a 3 minute holding time. Some products can make it as low as potentially 2 minutes of holding time. So, why is that variable? I guess compared to thermal processing, HPP is very much its efficacy is reliant on product composition. So typically, the lower the pH, which means there may be some acids in your product, that's going to help continue to kill or work on inactivating some of the sublethally injured pathogens and also spoilage microorganisms. because the product is going to be surrounded by water. You also want to have a high water activity in the product so that whatever is the pressure in the water surrounding your product is going to be equally imparted throughout your product. And finally, we also want to make sure that you have some flexible and high pressure compliant packaging that it can withstand a particular volume change, so that that's at the height of pressurization. But at the end of the day, a lot of HPP products do really, really well if food manufacturers keep in mind good manufacturing practices, certainly before and after the HPP treatment. So this is a diagram that I particularly like. It's developed by Cold Pressure Council, and which Hyperbaric and the University of Nebraska-Lincoln are a member of. So key benefits of HPP really address food safety concerns, certainly extend shelf life of products, also allows us to potentially reduce the amount of salts, nitrites, and other chemical antimicrobials that we put into the product. So at the end of the day, we get a clean label product. And most people that have jumped on and started to use HPP over traditional thermal treatments really enjoy the fresh taste and the fact that we're minimally processing the foods so that we can harness as much of the the original nutrients, vitamins, minerals, active components that are in the product that may be what we would call thermolabile or heat sensitive. So you wouldn't want to necessarily cook them in a thermal process. So the Cold Pressure Council has the high pressure certification program. And the goal of this particular council is to lead, facilitate, and promote industry standardization, user education, and consumer awareness of HPP. So, going to the topic in hand, how HPP goes hand in hand with sustainability. We mentioned shelf life earlier, shelf life extension. So, every time we extend product shelf life by HPP, number one, we certainly add value to the perishable goods. So, things that may only be seasonal or can only be grown in particular parts of the country, of the world, all of a sudden when we extend their shelf life, we start having the ability to distribute and support its market expansion so that more and more people can enjoy those foods. And I think that's great because a lot of different cultures that we learn about, we first learn about them when we eat their foods. And then finally, shelf life extension may also help reduce food and packaging waste. So every time these perishable goods are discarded, it's not just the food that we're discarding, we're also discarding the packaging that goes with it, and also a lot of the resources that were used to make it. So I'm going to talk about a project that I worked on back probably in 2018 when I first got started with HPP. We were actually approached by a national grocer. They were what do you call this? They were working with farmers to produce a lot of their products, and so they realized that there's some produce, perishable fruits and vegetables that are being grown, and sometimes they don't even make it to market. So it's not even that that they're not they're already expired, but just the fact that they're kind of ugly. They don't conform to the traditional look, size, or color that consumers are particularly looking for. So this definitely causes a major cost of food waste when consumers reject fruits and vegetables just because they're kind of ugly or they don't quite conform to our, what we think they should look like. Sometimes some of this food rejection may be outdated labels. Sometimes it's just defective packaging. The food itself is great, but perhaps the plastic crates we put them in or the cardboard crates that we put them in didn't quite make it throughout shipping. And like I mentioned already a couple of times, the consumer's misperceptions of food edibility just because it doesn't look quite standard. All three of these items, according to the FAO, the Food and Ag Organization, globally, this actually represents an avoidable food waste of about 45%. So I don't know about you, but that number really jumped at me because that's almost half of everything that we grow worldwide in terms of fruits and vegetables are being discarded because of these three reasons. So there's a couple of grocers that have started to actually, utilize or leverage the fact that they don't look standard as something that we should celebrate. So certain grocers have kind of branded them as misfits or imperfect or I'm perfect, peculiar picks or inglorious fruits and vegetables. So the grocers that we were working with, they had contracted a couple of farmers to grow their strawberries. And so strawberries, if you're familiar with them, they're highly perishable. They get picked from the ground from the plant and directly put into their crates, and then they go into a chilling room. Can't wash them. For those of you who have experience washing strawberries and trying to keep them in your refrigerator, know that they get moldy pretty quickly after you wash them. So their strawberries are also a dual usage crop. There's really no difference between the production of strawberries that are marketed in the fresh form and the production of strawberries for processing. So what does that mean? I grew up in Florida. Florida is a big orange state. California also produces a lot of oranges. California oranges actually look perfect. They're beautiful. They're really varieties where they're meant to be marketed in fresh form. You'll buy the actual orange. Whereas a lot of Florida oranges kind of look ugly. They're usually small, but they're very, very juicy and they have a very thin skin. So very easy to peel. So Florida oranges don't have to look pretty. They just have to be very juicy. And so that's the second part of this sentence that I put here. The second usage, if you will, for the oranges in my example would be the Florida oranges are really grown more for juicing or for processing, so they don't have to look pretty. We don't do that with strawberries. We just grow strawberries, and then we look at what they look like after they're ready to be harvested, and that's what we have to decide whether or not, oh, these look pretty, so they're going to go towards the fresh market. Whereas those that are probably not going to travel well, or they're already deformed or starting to mold, may have to think about diverting and using them for other purposes. When we think about strawberries, as I mentioned, they're very fragile, they're highly perishable. It's also one of the costliest agricultural commodities to produce. For every 1 pound of strawberries that you purchase at the grocery store, it really took 13 gallons of water to produce that strawberry. So if you waste that 1 pound of strawberries, you're actually wasting 13 gallons of water. On the right hand side, I have this pie chart, if you will. So this is the estimated total cost per acre of growing strawberries in the Central Coast in California. So as you can see there, a huge part of it, I think, is labor. These days, as more and more agricultural workers are becoming harder to find, if you start wasting the fresh strawberries that you purchased at the grocery store, or even as it's traveling throughout the supply chain, if it gets wasted or diverted from market or from processing and just discarded, we're also kind of throwing away all that labor that went towards producing it. So it's not just the physical food that's being wasted, but every other thing behind to get it up to that point is also going to be wasted. So this particular grocer that we were working with, that's kind of part of their conundrum. It's like, well, we don't want to just discard or throw away strawberries that don't look standard, or, the ones that are kind of starting to get fuzzy, or that they know this is overripe. It's going to mold before it ends up at the local grocery stores. We need to start processing them and diverting them towards something else. So one way that we can do that, extend the shelf life of fresh strawberries, is to freeze them. These days, we also have the option of freeze drying them. But both freezing and freeze drying are not what we would consider kill steps. It's not going to kill any pathogen or spoilage microorganism that is in that fresh strawberry. We still have to do something. So unless we start canning or making lots of strawberry juices that we thermally pasteurize, we need to have another process. So this particular grocer decided, well, can we have a strawberry puree that hopefully still tastes fresh? And so they started to look at HPP to kind of achieve that. So what we did was to actually look and see if we can have a 5 log kill, meaning can we use HPP to reduce the amount or the numbers of Salmonella, E. coli 0157H7, and Listeria monocytogenes in those fresh, highly perishable strawberries that are look like they're not going to make it to the fresh market. Can we HPP them at 87,000 psi for 3 minutes and achieve that 5 log reduction? So in the first graph that you see over there, the blue graph or the blue bars represent the amount of salmonella that we inoculated the products with. Usually our inoculation levels are somewhere around 10 to the 6 to 10 to the 7 CFU per mil or gram. In this particular case, I believe we did per milliliter because we pureed the strawberries according to the instructions of this particular client or the grocer. And then the gray bars underneath it represent what happens if you HPP them. And then in our method for enumeration, our limit of detection, or LOD, is at 1 log CFU per mil. And as you can see, for salmonella, we inoculated with 10 to the 7, and we were able to reduce it all the way to below the detection limit. So we're definitely able to achieve that greater than 5 log reduction, or a 99.999% reduction in salmonella numbers. The same can be said for the next set of bars underneath salmonella. These 2 bars represent E. coli 0157H7. And the same is also true when we do Listeria monocytogenes. So the data, the full set of data is not represented here, but we did monitor for pathogen recovery to see if at some point do any of these pathogens get above the limit of detection. And I could say that in a 70-day refrigerated study, we were not able to see any of these pathogens come back up. So that's great. I think having a a strawberry puree, make it to 70 days of refrigeration without any of these pathogens showing up is definitely a good thing. Definitely extended the shelf life of those suboptimal strawberries. The far right graph is what happens if we monitored for the typical spoilage microorganisms, so aerobic plate counts, yeast, and also to kind of just double check what is the pH of the product. Here, the 2 vertical bars that you see, the first set represent aerobic plate counts, both on what happened at day 0 and what happened at day 70. But both of those bars are HPP'd, okay? So the blue ones just represent at the beginning, immediately after HPP, and the gray bars represent 70 days of refrigeration afterwards. And as you can see, there is a small uptick in aerobic plate counts, but it's really not significant. We never saw yeast come back up again. And then there was a slight increase in pH as well. But again, it was not significant. So overall, we were able to retain, if you will, the quality of the strawberry throughout those 70 days of refrigeration. And I don't know about you, if I bought strawberries and pureed it at home without pasteurizing it, it probably will not last a week. So getting 70 days of refrigeration is actually really good. It allows the grocer then to potentially use this strawberry puree in other products in their market. This is a particular grocer that had a smoothie bar. So that's exactly what they did. They just kind of diverted a lot of these strawberries towards their smoothie bar. And during high peak strawberry season, that's what everybody was looking for, was for kind of a nice strawberry based drink. And so all those strawberries then were not wasted. So if I do kind of a quick comparison across different kinds of processing, as we mentioned earlier, fresh strawberries typically would have a 2-week shelf life. if they're near frozen, near 32 degrees Fahrenheit and 95% relative humidity. 3 days if they are just in a refrigerator, typically. You can freeze or dehydrate or freeze dry strawberries, and there you might get 12 months approximately of shelf life. So, having an HPP treated strawberry puree, where depending on the quality of the initial strawberries right before you HPP them, can probably get anywhere from a 35 to 70 day shelf life when refrigerated. And so, HPP definitely provides options towards extending the shelf life of fresh strawberries. So, moving on to another example, dark cutting beef. So, I come from the state of Nebraska, and we do a lot of beef processing in this part of the country. So, this was a kind of a fun project to look at. What is dark cutting beef? Again, it's something that looks like these, the right picture in this on this slide. So, a standard beefsteak is what it looks like on the left, and a dark cutter, so an animal when it is stressed right before it is harvested, may show up, a steak from it may show up like the one on the right hand side. The pH of this particular dark cutting beef can also be a little bit higher than the normal steak. So the higher pH actually just kind of makes it more susceptible to spoilage. So it might spoil more quickly than the regular beef steak. So recent estimates show that about 2.55% of the US beef that is produced is discarded just because of discoloration. Because I don't know about you guys. I mean, I'm just a regular consumer as well, like most people. If I were to go to the meat section in a grocery store and I see the steak that is on the left versus the steak on the right, I probably will buy the one on the left because I expect my beef steak to be like a bright cherry red rather than a dark brown or kind of a purplish steak. And sometimes what ends up happening too is that these um, dark cutting beef um, may actually be discounted in order to encourage the consumer to purchase it. So again, myself, if I saw these two steaks side by side, I might think, well, there's something wrong with the dark cutting beef because why are they discounting it? So I'm more likely to purchase the one on the left. So in 2019, it's been estimated that because of dark cutting beef, the US beef industry is losing an estimated $3.73 billion just because there's a certain portion of beef steaks harvested that end up looking like this. And there's really nothing wrong with them. It's just that, yes, that's just part of the animal's anatomy and the state when right before they were harvested. This is kind of what they look like. But losing that much dark cutting beef corresponds to approximately 194.7 million kilograms of beef, or almost 780,000 animals being wasted annually. So that's a lot of resources because growing beef is definitely very resource intensive. So we decided, well, HPP does tend to lighten beef color. So is there any way here that we can use HPP to just fix the problem? At least allow us to bring back value to the dark cutting beef because there's really nothing wrong with those beef steaks. So this is a project that a colleague of ours at Oklahoma State University and their graduate students decided to address. So the first picture that you have here, all of these are from the same loin. So USDA choice graded beef steaks. So the first one on the left-hand side is no HPP. This is at normal pH. The second one is a dark cutter beef. And this is no HPP. So I apologize. I said they all come from the same loin. They do not come from the same loin, but they did come from the same meat packing plant, and they were harvested roughly around the same time. So the first steak came from one animal. The second steak you're seeing, the one that looks dark brown, is coming from another animal. So then what happens? We took more of the steaks that came from that second animal. So they all start off looking like the second steak that you see on the graph here. And we HPP them for 90 seconds at different pressures. So the third one that you see there is 300 megapascal. It's a dark cutter. The second to the final one was processed at 450 megapascals for 90 seconds. And then the last one was done at 600 megapascal, and it was also started off as a dark cutter. And what we see is a mild HPP treatment. So not quite 600 megapascals where you would use that to pasteurize the product, but somewhere in between. You can actually improve raw steak redness without necessarily affecting the cooking and eating qualities of that steak. So it could probably pass consumer preference testing. Steaks treated at 300 megapascal did exhibit a brighter red color. So the third steak is starting to look more closely with the first steak, the one on the very left hand side. And it also has lower T bars, which is something that we measure in order to figure out or get an estimate um, of lipid oxidation or whether or not is the steak starting to go rancid. So that's something that is kind of nice. Is the third steak has being processed at 300 megapascals has a lot of benefits. Next steps then in this project is to figure out how we may overcome the lack of USDA grading for these steaks. So let's say a dark beef cutter beef steak ends up being HPP'd. Well, meat grading occurs when it's still the whole carcass of the animal, kind of what you see in the diagram here. And then once they're graded, then that's when they get cut into the different cuts and also where the steaks are going to be fabricated. So for us, for HPP, it's highly unlikely we're going to HPP the whole carcass. We're just going to HPP the steaks after they've been cut. But after they've been cut, there's no more grading. So we'll have to probably, as an industry, if this is something that the US beef industry wants to do, maybe have to figure out a way to regrade, let's say HPP treated steaks, or have some kind of a labeling, so just so that everybody knows that we got it back to the red color after it's been cut up into the beef steaks. So watch out. This may be something that's coming to your local market in the future, but it certainly is research at this point. Okay, another example of capturing or upcycling value would be, let's look at what we've learned from the raw pet food industry. So for those of you who are not familiar, pet food industry is a huge industry. Most of what you purchase now in the market are highly processed products. But then there's a small fraction of the industry that's starting to look more and more into the minimally processed or raw pet food segment. So within the raw pet food segment, you have raw meats and other ingredients being combined. Usually, the raw meats and those ingredients come in frozen into a plant. They're tempered, ground, mixed, and then packaged. So, but since everything is raw, and we know a lot of it has meat byproducts in there. So think about some of the mechanically separated meats from the bones, or certainly a lot of organ meats like livers and kidneys being added into to the pet food. That needs to be pasteurized in order to reduce or inactivate the Salmonella, Listeria monocytogenes, and also E. coli 0157H7. It's for both the safety of both the animal, but more importantly, of their pet parents or the actual consumers, because those pathogens can sicken or even kill somebody in the household. So we need this, what we call a kill step. So traditionally, we would use a thermal process, but in this particular case, the raw pet food industry, a lot of the companies have started to use a non-thermal pasteurization technique, and usually they rely on HPP. So that knocks down all of those pathogens And then it'll go through another series of operations. So there may be a cooling step. Material may be ground up again or shredded, formed, let's say, into nuggets or patties or little bites. And then they'll go potentially go into a freeze drying step. But eventually, everything is packaged, and there may be another post lethality treatment. Um, and but the goal at the end of the day is to have a shelf stable product, because a lot of pet owners are still accustomed to handling dry kibble, if you will, but they don't necessarily want kibble. They want a raw pet food product. So the raw pet food mimics the look and the shelf stability of dry extruded kibble. But there are some raw pet foods out there that are just refrigerated. Usually they're sold like a meat chub, if you will. And then there are some that are definitely sold frozen, purchase them frozen, and you don't thaw them out until right before use and fed to your companion animals. So there's a group of people that realize, well, that's very similar. That's a process that we can utilize into making some nutraceuticals. In the area of nutraceuticals or dietary supplements, they're looking for something that's premium, something that's functional. So people who tend to feed raw pet foods are people who believe that there's still a lot of nutrients, vitamins, minerals, certain enzymes that are in the raw meat ingredients that they want their companion animals to consume. So, because they believe it has a lot of function to it still. So that's something too that a lot of folks that are drinking dietary supplements are interested in. They want something functional. They want something natural or minimally processed. And they definitely want something that is sustainable. So a lot of the products that you're seeing here on the screen are dietary supplements that are actually based on animal byproducts that would have either been sent towards rendering or to a foreign market where a lot of other cultures tend to eat organ meats more so than we do here in the United States. And or they could some of these ingredients that you're seeing for these dietary supplements may end up getting put towards pet foods. So nutraceuticals or the dietary supplements industry is now looking at, well, maybe HPP could be a way for us to pasteurize what and still retain the nutrients that are in these animal byproducts. So the dietary supplement industry is a really big market. 4,000 products all the way back in 1994, and about 7 years ago, it was 90,000 products that were in the U.S. market. A lot of surveys indicate that more than half of US adults will consume or currently consume dietary supplements. And the economic value of this industry is projected to reach nearly $60 billion in the US and almost $200 billion worldwide by next year. So it's definitely a growing industry. So, as more and more individuals use dietary supplements, there's going to be a renewed focus on the risks associated with these products, and the regulatory processes involved in bringing them to market is going to be needed, because more and more people want something raw, natural, or minimally processed. And when you start using those words, first thing that comes to a lot of regulators' minds and a lot of food safety experts is, well, what are you doing in order to make sure that the product is safe? So that's an area where HPP can certainly play. So if we look back at the raw pet food industry and we use a similar kind of process diagram, for most of these dietary supplements, you have a single organ meat being processed and bottled up. So imagine having some of these organ meats arrive in a food processing facility, coming in frozen. They'll be tempered, ground, packaged. They'll need a kill step. So maybe HPP is one of those kill steps that we can use in order to preserve some of the heat sensitive nutrients. And then they'll be dried, milled into a powder, and then bulk packaged until somebody can encapsulate them. And sometimes you don't even have to encapsulate them, just put them in a jar, because people are going to add it as additional proteins, if you will, potentially to, let's say, their milkshakes or other as an ingredient into something that they want to eat. So, but at the end of the day, most consumers will want some kind of a shelf stable product. So I think this is great overall, once again, for the animal food industry. Because if I look at a whole animal, whether or not it's chicken or it's pork or it's beef, we don't eat a lot of the animal. Approximately 50% of that animal is actually considered inedible. The rendering industry does a really good job of recycling and or more importantly, upcycling those inedible parts. Pet food industry also does its fair share. And now it looks like we may have a third industry come in and also help upcycle those meat byproducts. So I think overall that's great. And then finally, this is the last topic that I wanted to cover in this presentation. HPP can also be used a lot in developing bioactive peptides. So imagine those organ meats that I just had in the previous slide. Some of them are just full proteins. And what my protein chemist friends tell me, when you have these large proteins that are really a sequence of amino acids, um, it does have a function in the body, right? Helps build muscle. But if you want to harvest additional function out of it, you're going to have to start cutting it up into smaller subunits. And those smaller subunits, depending on what are on the ends of these peptides, could be very, very active. So, some of the benefits of consuming bioactive peptides, and this may be familiar to those of you who are drinking or consuming collagen peptides, you start seeing some benefits where you might get some anti-hypertensive properties. Certainly, you do it for antioxidants. For those of you who are using, let's say, face or skin creams, anti-aging creams, if you look at the product label, it'll point out some collagen peptides to it. Some of these peptides may also have some antimicrobial properties, and some of them may be also have some cholesterol lowering properties. So, how are bioactive peptides produced? So, usually you do an enzymatic hydrolysis, a gastrointestinal digestion. Certainly, microbial fermentation could be one, chemical digestion, recombinant production, or chemical synthesis. All of these require chemicals, and sometimes it can take a long time to go through an entire hydrolysis or an entire fermentation cycle or an entire digestion cycle. So this is where HPP, I think, can help quicken some of those processes. So let me just show you, I guess, this slide. It has two supplemental facts panel taken from bottles of what do you call this, dietary supplements out there. On the left hand side would be a collagen protein product if you were to purchase it. So the serving size is one scoop or about 11.3 grams. As you can see, that one scoop contains 40 grams of calories, 10 grams of protein, 40 milligrams of sodium. And then if you look at the collagen, what's in there? So bovine collagen, so something from beef, chicken collagen, something from chicken, eggshell membrane collagen, and a fish collagen. That's great. But remember, those are just the proteins. So they're really, really long units of amino acids. But on the right hand side, after a process where you cleave or cut up that protein into smaller units, again, one scoop of this hydrolysate or a peptide type product contains 10 grams overall in that one scoop. You have almost the same amount of calories, proteins, and such. But if I look at the ingredients list, a multi collagen complex, you start seeing the word peptides, right? So hydrolyzed bovine hide collagen peptide. You also see hydrolyzed fish collagen peptides. So the product on the right is going to give you more function than the product on the left. So a consumer purchasing the product on the left is purchasing it because they want additional proteins in their diet. But the ones purchasing the product on the right are purchasing it because it's going to provide them with some kind of function. And that is based on whatever the manufacturer is saying, according, hopefully, to some studies that they're conducting themselves. So, some examples of how HPP can be used to produce bioactive peptides. A lot of this is still in the research phase, but this is one paper published all the way back in 2013, so over 10 years ago, using HPP 600 megapascals for 15 minutes with a protease. So it's an enzymatic hydrolysis process. It improved the amount of hydrolysis or the degree of hydrolysis, meaning it was HPP helped it cut those huge proteins, bovine collagen in this particular case, much more efficiently. And it also increased the ACE inhibitory activity of the peptides. So ACE inhibitory goes along with something hypertensive, so anti-hypertensive. Um, this is an example where I kind of find it funny. They called it mushroom foot protein. So I had to think about this for a long time. What would be a mushroom foot? And what it is the actual bottom of a group of mushrooms that like you see here. Usually those are discarded, so that's a waste within the mushroom industry. But if you process it with ultra high pressure processing, it actually helps the release of bioactive peptides after you introduce a protease or an enzyme to hydrolyze it. And in this particular case, they actually used a milder pressure, 400 megapascal, and applied it for 10 minutes. Another example, eggs, right? So here, really low levels of pressure, 200 to 400 megapascal, even for 1 minute with another protease, chymotrypsin or trypsin. So that's another protease. So we're looking at an enzyme hydrolysis process. So here it promoted, again, cutting up egg proteins and the release of bioactive peptides from the ovalbumin. So in this particular case, those peptides actually had a lot of anti-hypertensive properties to it. And then I think finally, this is my last example. This is using lentil proteins. So again, HPP with a particular kind of enzyme. So in this case, Zavinase enzyme. HPP allowed it to release more of the peptides with some antioxidant properties. So HPP in this particular case is also a very mild pressure, 300 megapascal, applied for 15 minutes at a elevated temperature, so 40 degrees C. So even though these at this point are still at the research phase, I think there's tremendous opportunity here for HPP not only to provide pasteurization of a material that, maybe we only consume or produce because of its protein amount. But what if we can actually improve protein quality, or more importantly, the quality of the peptides that we can get out of those proteins? Or in the particular case, like the mushroom foot, or potentially some of the ovalbumin waste from the egg industry, if we can upcycle those rather than just discarding them or selling them because they're proteins, what if we can sell them because they're bioactive peptides instead? So there's a function associated with it. I think that's tremendous opportunity for HPP industry to again expand. And I'm kind of a believer that the more uses of HPP that we can figure out, some of the emerging or new applications of the technology, I think over time what we're going to see is the cost of using HPP then to process more products is going to kind of come down. So it's overall good for the industry, and more importantly, also good for the consumers. We're trying to harness as much good stuff as possible out of anything that would be discarded or anything that is undervalued. Um, so, with that, I do appreciate everybody's attention. I hope you enjoyed this presentation, or at least learned something from it. Sustainability, like food safety, definitely spans the entire supply chain. We saw that with the strawberries. It doesn't have to be at the very end of the process. We can introduce HPP in the middle of the supply chain and try to raise its value. And hopefully, down the road, we can use HPP to extract more nutrients from foods and produce more bioactive peptides. So, with that, Daniela, thank you again for giving me this opportunity and happy to discuss any questions you have.
Thank you, Mary Grace, for this pre-presentation with a lot of useful information and great takeaways. So, as you mentioned, now we're going to pass to the Q&A session. So, the
Mhm.
first question is, what category of food products has the greatest potential for growth in terms of upcycling raw materials?
Yeah, so I definitely think, and maybe I'm biased because I'm coming from the state of Nebraska. If I look at, how intensive are some of our production, everybody always says animal meat production is really intensive. And then the statistic that I put up there, the fact that, almost 50% of an animal is inedible. I think that that is a category that we can definitely try to upcycle as much as possible. As I mentioned earlier, the rendering industry does a really good job of that. Pet food industry does as well. So HPP could be a third option. And again, it just kind of depends on what final products we want to get out of it. So,
Thank
yep.
you, Mary Grace. So, the second question is, what advice will you give to those looking to get started upcycling raw materials? Are there any common pitfalls they should avoid?
Yeah. So, and this is kind of interesting. So, in my work in the food processing center, we've definitely had some companies contact us, right? Saying, well, this is what our company does. This is our main gig. We make this product, but then we have all these things that we tend to either just discard or donate, or we pay somebody to take it away from us, right? So, is there anything that we can do there? So, a lot of the kind of ideas that they come up with, are valuable. But at the end of the day, what makes upcycling marketable or sustainable would be you kind of have to do your homework and really think through who's going to be the new market, who's going to purchase that material, and can you sell it at a higher cost than what you're currently doing now. Because so for one example that I had was, we had some companies approach us and say, well, we want to do and reprocess a lot of like eggshell membranes, so discarded eggshells, because most of the time, maybe it's just used as for land application. um, and I think at the end of the day, we calculated, the amount of proteins that you can get out of it, the collagen, and then what it would it take for, let's say, a company to not treat it as waste and instead divert it for more processing. And what we found was that it was going to cost a lot of money just to kind of get collagen peptides out of it. Right now, really the most economical way for them to deal with that particular raw ingredient, the eggshell membranes or the eggshell waste, would be for land application. So, but that doesn't mean that in the future it won't be a reality, right? So for example, the more, if there really is a market for more eggshell membrane peptides out there, then once that market is created, then there's going to be a demand for it. And all of a sudden, the demand for it is going to be more profitable there rather than just applying it towards land applications. So, yep. So I think that's the thing. It's like you have, yeah, if anybody trying to go into upcycling, I think it's great. It's wonderful, but there's a lot of homework to be done.
Of course, yes. And finally, the last question is, you mentioned that HPP helps extract thermolevel compounds. Which other nutrients are favored in terms of availability after HPP?
Yeah, and so I think in this particular case, I really would look at, the raw pet food industry right now because I think they're the leaders in having utilized HPP. When you think about it, their goal is to make sure that they're still producing a complete and balanced nutrition for pets. So, but they want to do it in a way where a lot of their raw ingredients are really coming from meat byproducts. So, as much as possible, they're trying to at least maintain the quality of the nutrients that are in those meat byproducts, or even trying to elevate them as much as possible through processing. So in this particular case, there's been a lot of work in the raw pet food industry that you're not only looking at some of the nutrients, but you're also looking at potentially, let's see, trying to make sure that with HPP compared to thermal processing, you're not creating any kind of Maillard reaction byproducts that tend to be bad for the health of the animals. So I think that something like that is another set of nutrients that we're trying to preserve with HPP.
Great. Thank you so much for all these useful and constructive answers, Mary Grace. And for now, I'm going to end this HPP Innovation Week. Thank you for joining us again. It's always a pleasure to have you here in these spaces, the educational spaces, to share our time with you. So thank you again, and thank you everyone else for joining us today.
Thank you. Appreciate it.